The process begins by making a pattern of the part. In this case, it's a padeye for mounting a new set of whisker struts. I'm using basswood as it has a smooth, even grain and is easy to work. Because I needed multiple identical copies, these grabrail brackets were 3D printed. The total cost to have the patterns and the matching core mold printed was about 20 bucks, which saves a lot of delicate carving. The patterns are painted with a shellac-based primer to smooth out the texture and seal them against the moisture of the sand. The patterns are arranged in the drag half of the mold, and parting compound is dusted over them. The first layer of sand is riddled through a screen over the patterns. This is green sand, so called because it contains water as a binder. The sand is compressed firmly around the patterns in several passes. The second half of the patterns are then added, and the cope mold is placed on the drag. Here, patterns for the sprue and riser have been added as well. Pattern removal is tricky business. They are wrapped and wobbled to break the bond with the sand, and very gingerly removed, trying not to catch an edge or otherwise destroy the hard work. In the end, any sand that falls away makes positive space. In other words, it's bronze that can be ground away from the final part, so it isn't a total deal breaker. Ingates are cut manually into the cope. They need to end up smooth with no sharp edges to erode away by the flow of molten metal. The idea is the turbulent metal flows down the sprue, out the runners, and then fills up into the gates, thereby having a smooth flow and hopefully not bringing any loose sand into the final part. Because a hollow is needed in the handrail brackets, a core is required. The base for the core sand is just standard green sand allowed to dry fully overnight. The cores are baked at 350 degrees Fahrenheit for about an hour. Because of the molasses, they smell great while baking. When they come out of the oven, they are rock hard. The cores are placed into the mold, resting on the shelf defined by the core print on the pattern. These are oval, so they must be clocked rotationally as well. Mold halves are clamped firmly, as the buoyant force of the liquid metal is enough to float the cope and cause leaks. When the bronze is molten, the dross and oxidized metal is skimmed off the top. Don't underestimate how heavy 20 pounds of bronze feels when it is 2,000 degrees. Due to the thin wall, failures were common at first. Success was much easier with the heavier whisker strut fitting. I improved the gating design to allow for faster filling, and increased the pouring temperature for the next round. Luckily, with silicon bronze, very little of the alloying elements burn off during melting, so bad parts can be remelted and used again. The remaining parts for the whisker strut required sneaking into the machine shop at work after hours. Finally, whisker stays that clear the new anchor. Time for a test sail. Back to the shop to finish up the grab rail. The core mold makes a handy template to check progress. The fastener holes were drilled through slugs of cured epoxy to prevent water damaging the wooden cabin top. A ring of butyl tape seals the base of each bracket. Blind fasteners are used, bolts passing up into matching threaded holes in the brackets. Thanks for watching.